lesson 27. We're going to do the homework that looks like the test and all. We've already done 1 through 4 because that was lesson 26. So now we're on number 5. So number 5, it says solve each equation if x is between 0 and 360 degrees. 0 is less than or equal to x is less than or equal to 360 degrees. And we want to find sine x equal 1. Here's what that means. That means that we're limited to 0 to 360. That's 0, 90, 180, 270, 360. In other words, we're not going around and around and around and around and around. We're not doing 2 pi k. Okay? So, we go to our memory bank. The sine of what is 1? Well, the sine of 90 is 1. But sometimes that happens at more than one place because of reference angles and such. But we're not dealing with a reference angle. In other words, if I had like sine 30 was equal to a half, or sine something was a half, and I said, well, that's 30, I would be thinking, well, that could be here, or here, or here, or here. So there's 4 possible places that scenario could happen if it was 30 degrees. And then I would have to look at the sign and say, well, where is sine positive at, you see? But we're not dealing with an acute angle like 30 that would have 4 reference angles. We're dealing with a what kind of an angle here? A quadrantal angle. And on a quadrantal angle, we deal with that angle, and then we deal with the other direction on that quadrant. So if we're at 90, we're going to deal with 270. But what is the sine of 270? It changes the sign -1. So is the sine of anything else 1 besides 90 between 0 and 360? No. So my only answer is 90 degrees. But we had to think that out to see if there was more than one answer. That makes sense? So sine of what is 1? 90. So the sine of what is 190, is there anywhere else that would appear again? No, because if we were to reflect down to 270, it would change the sign to negative, and so that's the only answer to number 5. Now, if we go to number 6, we've got cosine of what is square root 3 over 2. Now, we have to go to our memory bank and say, well, the cosine of what is square root 3 over 2? Well, they're 30 degrees, as I was talking about a while ago. And we say, well, but where all would that happen as far as reference angles then? Well, as far as reference angles, 30 degrees in quadrant 1 would be 30 degrees. 30 degrees in quadrant 2 would be 30 degrees before 180, which would be 150 degrees. 30 degrees after 180 would be 210 degrees. 30 degrees before 360 would be 330 degrees. So our brain first says cosine what square root 3 over 2 as far as our first little piece of memory work, and we say, well, that's 30. But then we say, well, what are all the possible angles that have a reference angle of 30 between 0 and 360, and it's 30, 150, 210, 330. But then we've got to think, well, the answer here is positive. So we got to think, well, what's positive where? Well, they're all positive in quadrant 1, sine in quadrant 2, tangent quadrant 3, cosine in quadrant 4. All right, so we're thinking, okay, now where is cosine positive? And we know that cosine is positive in quadrants 1 and 3. So we're going to take the 1 and 4. So So we take the 30 degrees and the 330 degrees. Any questions on that? Okay. So that's connecting everything we talked about yesterday. Pretty good with that. Okay, number 7. It says, evaluate each expression. Assume that all angles are in quadrant 1. They're saying that because everything is positive in quadrant 1, right? So you don't have to try to figure out, is it going to pop back into a positive or is it going to pop back into a negative, because what was that really? So that gets rid of that issue. And so number 7, what we have is tangent of this little guy. Now, first of all, what is that little guy? How do you say that? That's arctangent, abbreviated. Now, what do tangent and arctangent do to one another? They cancel each other. They're not reciprocals. What is the reciprocal of tangent? Cotangent. That's when you flip it over. We're talking about an undoing thing. What undoes tangent is cotangent. What undoes tangent is arctangent. And so the tangent of arctangent is 2/3. They just cancel each other out. Okay? Now, we're going to do some calculator stuff later just because we need to before we quit this video, because we're doing it on paper first, but then we need to show you how to do it on calculator so that when you get to the calculator, you don't make mistakes just entering it in. But so no, we're going to deal with that before we're through. Number 8, we have cosecant of arc sine of 1. Cosecant of arc sine of 1. Now, let's think about what that means. If we're doing, let's go back to this one. Let's go back to the one before it. If we're doing arctangent, what does that really mean? What are we trying to do? We're trying to find the degree. So what we're really doing right here, if we back up to number 7, we want to know what degree is associated with 2/3. Now, that's not one of our memory things. But if it was a certain degree, we'll just put x degrees. That turns into x degrees. Now, if we go back and do tangent of that same degree, we're going to end up with that number again. Okay? So what we did is we did arctangent, which gave us the angle, and then we did tangent of the angle, which gave us the ratio. So arctangent gives us angle, tangent gives us ratio. What's arcsine going to give us? Some degree. So we're going to have cosecant of some degree. We want to know what angle has a sine of 1 in quadrant 1. What angle has a sine of 1? Well, it's going to be the quadrantal angle 90, and we're going to use in quadrant 1 the quadrantal angle attached to it also. And then cosecant. Cosecant is what? Reciprocal of sine. So then we need to think, okay, I want 1 over sine of 90. Now, what is the sine of 90? 1. And so I have 1 over 1 is 1. Just happen to be the same because the reciprocal of 1 is 1. Okay? Any questions on that? Do we need to do another example or two there that's not in the book? Is everybody fine with that? Do I need to make something else up? Yeah? Let's throw another in there for just in case. We'll call this 8.5. 8.5. Okay, this is number 8.5. let me make something up. Let's do the cotangent of the arc sine of the square root of 3 over 2. That's probably a good one to mess with. Okay, so let's play with that and just see what happens. So we get one more crazy one. So first of all, we're going to do what's in the parenthesis first, if you want to follow that little order of operations thingy. Arc sine means we're looking for the angle that has a sine value of square root 3 over 2, which is 60 degrees. So arc sine square root 3 over 2 is 60. So what we want now is cotangent 60. Now, cotangent is 1 over tangent. And so we're going to have 1 over whatever tangent 60 is. Everybody follow what we're doing there? Now, what is the tangent of 60? Square root of 3. So we get 1 over square root 3, but we have to rationalize. It's probably good that we made this example because anything crazy like this can pop into that section also. So that gives us one more example of something that might be a little bit twisted. They say we got that. So it's all memory work. We hadn't hit a calculator button yet. Okay? You probably would have needed to hit a calculator button on number 7 because there's not a 2/3, but we knew that tangent canceled arctangent, so we didn't have to. Okay? Any questions so far? Now, number 9, it says if m, now, I'm trying to be careful when I write these. We have little m, little p, capital M. Notice that when we draw a picture like this, and this is standard situation, if we have a right triangle and we have angle M, angle N, angle P, then little m is going to be opposite angle M, and little n is going to be opposite angle N, and little p is going to be opposite angle P. That's a standard way to write it. So if the picture wasn't drawn, you would know you could draw a picture like that. You kind of need to know, though, where your right angle's at. But anyway, so here we go. So we've got number 9. It gives me that little m is equal to 8. It gives me that little p is equal to 14. And it gives me that we want to find angle M is what we're looking for. Now, if I put that in the picture, I've got that little m is equal to 8 and little p is equal to 14, and I'm looking for angle M. Now, what am I going to use to try to find angle M? Sine, cosine, or tangent, a trigonometric ratio. And when I do that, remember there's 4 slots, right? I'm just going to draw these rectangles one more time. We're going to have some function of some angle is equal to one side over another side, right? And we do the angle first, the ratio, the function second, and the ratio third, right? That's the order we set up a trigonometric ratio. So the first thing we're going to do to set up the trigonometric ratio is identify the acute angle, and if it's the one we're looking for, then that's what we would put in that slot, right? And so we're going to put in that slot angle M. And then what do? We see how the sides given are related to the angle chosen. And so the 8 is the leg opposite of angle M, and the 14 is the hypotenuse, and leg opposite hypotenuse is sine, so that tells us that the function we use is a sine function. So we fill in the function slot second. And then to get our fraction or our ratio, we do it the way sine says to do it, and sine says to put leg opposite over leg adjacent. Over hypotenuse, thank you. Leg opposite over hypotenuse. There we go. I was thinking of the next step, and I forgot what I was talking about. Now, we want to undo. We're trying to isolate the variable, right? So we want to undo sine, and you undo sine with the inverse of sine. And what do we call inverse of sine? Arc sine. Arc sine cancels sine. So in the calculator, we would punch second sine, 8 divide 14. Now you got to have it on degrees first, right? Is everybody ready to go to the calculator? Okay, so we're going to go to the calculator, and we're going to make sure it's in degrees. So we'll go to mode. We're in degrees. That's good. To get to sine, to get to arc sine, you have to hit second sine. It's sine -1, right? And so we have arc sine of, I forgot the numbers, 7, 8/14. There you go. 8 divide 14. And we would get 34.8 rounded to the nearest tenth, 34.8 degrees. Everybody say we got that. Now, let's talk about something. It froze up. Let me pause. No. Yes, I am. Okay, so, sorry about that little leak in the volume there. And that's made it worse, didn't I? Added to it. Anyway, here we go. We need to know the difference in a couple of things. So I'm going to ask questions, and we're going to see what happens. What if I wanted to find the inverse sine of 0.5? I'm going to put a half, just so we can see it like that. Okay, inverse sine of 1/2. Now, what does that mean when I punch that in the calculator? It means the sine of what is a half. And what's the answer? 30 degrees. Okay, so sine to the -1, which we actually hit second sine to get there, really is arc sine, and it's saying what angle has a sine of a half. Okay? Now, what if I did this? What if I said sine 30, and then I hit this x to the -1 button? Now, let me go back to that. So we've got sine of something to the -1, and we have sine -1 of something. Those don't mean the same thing. Now, let me show you how I got the second one, and I appreciate the answer, but I'll let you get back to it in a second. What we did is we hit sine, and then we hit our 30 degrees, and then we hit the x to the -1. Now, what is the x to the -1 button? It is the blank button. It is the reciprocal button. So it says the reciprocal of sine 30. So what is sine 30? 1/2. What's the reciprocal of that? 2. So this says the reciprocal of sine 30. Sine 30 is a half. The reciprocal of that is 2. Everybody understand the difference in those two sets of keystrokes? We have to know the difference in that. Okay? So the second sine button is the arc sine button. The x to the -1 button is the reciprocal button. Okay? What did we just find right here? We found the cosecant of 30 degrees. Because what is the reciprocal of sine? Cosecant. You understand what we just found? When you find the reciprocal of sine, you found cosecant. When you do arc sine, you found the angle associated with that. They see the difference in that stuff. Because we got to know what we're doing on the calculator. Okay. All right, so that's got that one. Let's look at number 10 then. We'll put the calculator away for just a second. Let me get that back on a toggle switch there. Minimize the calculator. All right, so we're back to our home screen. We're on number 10. Number 10, we had, that was a little slow. We have m is equal to 14.3, little m. Good. We have little n is equal to 18.8. And we want to find angle n, capital N, angle n, n. Too many loops. Okay. Now, if we go to our picture, we need that picture, right? We had m up here and n down here. And we got little n is 18.8. And we have little m is 14.3, so that's where everything lands in our picture. We're going to solve using a trigonometric ratio, and when we do, we're going to pick what first? The angle we're looking for. And so the first thing we would write down is angle n. And then we would see how the sides given are related. The 18 is the leg opposite. The 14 is the leg adjacent. Leg opposite, leg adjacent is tangent. So that tells us we're using the tangent ratio. Understand that? And then we set up our ratio according to what tangent says. And tangent says you put the leg opposite over the leg adjacent. Now we're trying to solve for n, which means we want the junk off of n, the way we said it in Algebra 1. So we're going to get the junk off by doing the inverse. What's the inverse of tangent? Arctangent. So we'll do arctangent, which cancels tangent, and we get angle n is equal to, so we're going to hit second tangent 18.8 divided 14.3. Understand that? So, to the calculator we go. So we go second tangent, 14.4, I believe, divide 18.3, is that correct? 18.8. That was bad. 18.8 divided by 14.3. Ah, weird. I'm not hanging on to stuff good today. Close. Enter. 52.7 degrees. 52.7 degrees. Any questions on that? All right. Any questions so far? All right. The next two say solve the triangle described. Now, when it says solve the triangle, that means find every missing piece. And what we're going to do is just go ahead and find every little piece. So we're just going to write down everything. So if it says solve triangle ABC, and we're going to go ahead and draw triangle ABC so we have all our stuff in the right place. So we have angle A, angle B, angle C, opposite A is little a, opposite B is little b, and opposite C is little c. And it's solve it, and so we want to find angle A, angle B, angle C, side A, side B, side C. When it says solve it, it means give us every little piece of it. Now, it gave us angle A was 35 degrees. So we obviously have that. It gave us that little b is 8. Whoops, little b is 8. And with that, we'll have everything else. So we're going to use trigonometric ratios, Pythagorean theorem. We've got a 35-degree angle. It doesn't matter which one we find first, A or C, correct? You could actually find the other angle already, and you could have used it instead of 35, right? Because the sum of the angles of a triangle is 180, or we could say the acute angles of a right triangle are complementary, so 90 minus 35 would be 55. So angle B is 55 degrees. Angle C was your right angle, 90 degrees. So when we go to choose an acute angle, we could choose the 35 or the 55, whichever one you want to choose. Okay? If I use the 35 and I'm looking for little a, then what I would have in relationship to the 35, the little a would be the leg opposite, and the 8 is the leg adjacent. Actually looking for little a, I would use leg opposite, leg adjacent, which is tangent, and then I would put leg opposite a, little a, over leg adjacent, 8, and I could set up a tangent ratio to help me find little a. Leg opposite, leg adjacent. Remember, to solve, we're going to undo. We're not going to do the trig ratio until the very last. The 8's would cancel, and so little a would be 8 tangent 35. So we would punch in. I'll go ahead and do it here. No, I'm not, because I'm going to lose everything. So somebody tell me what 8 times tangent 35 is. 5.6, rounded to the nearest tenth. So little a is 5.6. It may not even have had to have been rounded. So little a now is 5.6. Now how could we get little c? We could do the Pythagorean theorem, or we could do another trig ratio, right? Let's just do the Pythagorean theorem. We could say a squared plus b squared equals c squared. So a, which is 5.6 squared, plus b, which is 8 squared, is equal to c squared. 5.6 squared is 25 plus 6, 31, 36, 31, 36. 31.36. Plus 8 squared is 64 is equal to c squared. We would add and we would get 95.36 is equal to c squared. Get rid of the square with the square root, and we would get c is equal to 9.8 rounded to the nearest tenth. So now we know every angle measure, we know every side, so we have solved the triangle. Any questions on that? Okay. Number 12. Let's go ahead and do that one, even if we do that one fast. Okay, this time they gave us that little a was 3.8. They gave us that little b was 4.2. So little a is 3.8, little b is 4.2, angle C is 90 degrees, and that's all we know. And we don't have either of the acute angles, so we're just going to have to pick one to try to find first, right? So let's just say that we want to find angle A first. If we want to find angle A first, then we would write it down as our ratio, angle A. We would see how the sides given are related to angle A. The 3.8 is the leg opposite. The 4.2 is the leg adjacent. Leg opposite, leg adjacent is tangent. understand it. Tangent says you put leg opposite over leg adjacent, and so we have a trigonometric ratio. We're trying to solve for A, so we want the junk off. So we're going to undo tangent with its inverse, which we call arc tangent. Arc cancels tangent. And so we're going to do arc tangent 3.8 divided 4.2, which is 42.1 degrees. So that gives me that angle A is 42.1 degrees. I know that the acute angles of a right triangle are complementary, so I can say 90 minus 42.1 is 47.9 for angle B. The acute angles of a right triangle are complementary. They add up to 90. To find side C, I can do the Pythagorean theorem again. So A, which is 3.8 squared, plus B, which is 4.2 squared, is equal to C squared. 3.8 squared is 14.44, plus 4.2 squared is 17.64, is equal to C squared. We're going to add and we're going to get 32.08 is equal to C squared. 32.08 equals C squared. Now we get rid of the square with the square root, and we get C is equal to 5.7 rounded to the nearest tenth. And so we found every angle and every side of the triangle, so we solved the triangle. Any questions on lesson 26 and 27? All right. Appreciate your attention.